Hello, my name is Pablo Galaso. I work at the Institute of Economics of the University of the Republic in Uruguay. And together with my colleagues Carlos Bianchi and Sergio Palomeque, we have developed the research that I'm going to present you in this video. This paper presents parts of the result of the research project that has been funded by the National Agency on Research and Innovation from Uruguay, which its main purpose is to analyze collaboration networks associated with the processes of invention and patenting in Latin American countries during the last half century. So let me start with a brief theoretical introduction. The theoretical framework we use in this study is based on two fundamental research fields. First, the innovation system approach that allows analyzing critical aspects of innovation, such as distributed property of knowledge and interactive features of innovation. In fact, the innovation system has been defined as a network of actors who interact in the process of generation, diffusion, and utilization of new knowledge. And in this regard, the social network approach is particularly suitable to capture systemic properties of innovation processes and consider that both the role and the position that each agent holds in the innovation processes are crucial to understand the systems of innovation. Both the innovation system and the social network analysis literature have extensively analyzed the absorptive and openness capacities that are critical features of innovation. The absorptive capacities refers to the capacities of the system, of the actors and the interactions to absorb critical knowledge for innovation processes. And the openness capacities is the capacity to connect with external actors that can bring the system valuable external knowledge that can be used in the process of innovation. In this regard, there is another stream of research that is interesting for our study, that are the critical contributions that have been made from the Latin American studies on innovation. Those studies have revised the theoretical concept of innovation system in the conditions of underdevelopment. In this regard, authors have characterized Latin American innovation systems with two characteristics. Basically, they have said that they are immature and incomplete, stressing the weaknesses of connectivity and absorptive capacities. And also previous research has widely shown that Latin American innovation systems are highly open systems, holding a peripheral role in the world knowledge networks and with a great dependence of external actors, which play a key role in innovation processes in the region. So here we find a research gap, even that there is the data availability and information processing capacity have dramatically increased. Several studies are claiming that this is necessary, a comprehensive research based on standardized data for the entire region. And also, previous research has pointed out there are challenges to analyze innovation systems dynamically along a relatively long run period, which allows to capture the evolution of the innovation systems. So in this regard, this research, this paper aims to address these challenges, analyzing collaboration networks from invention and patenting activities in Latin America. Our study makes three relevant contributions. First, we obtain empirical evidence about a wide and a very diverse range of countries, providing novel comparative analysis of network structures in multiple nations that has different sizes, different levels of economic development, and heterogeneous institutional frameworks. And second, our analysis covers a long and relevant period, which allows us to observe how innovation systems may evolve and may respond to changes in the environment. Finally, our study combines networks with different types of nodes, different links and geographical perspectives, and this allows us to provide a broad and exhaustive overview of the innovation systems in Latin America. Let's present briefly some methodological issues. First, regarding the data, we use patent records retrieved from the Patents View platform. This platform incorporates disambiguated data on inventors and on owners. And this ambiguation is critical for analyzing patent networks because it allows determining if inventors that are registered with the same name are not the same actors. Also, this patent data in the US allows for the geolocation of inventors and owners, which is also critical for our study. And in order to identify inventions that have been developed by Latin American actors, so that inventions that have been carried out from Latin America, we select only the patents with at least one inventor that is located in a Latin American country. So following this selection, we ended with a database that includes more than 17,000 Latin American patents registered in the US, covering the period from 1970 to 2017, and accounting for 0.25% of the total database. How we elaborate the network? We present here an example of a table with three hypothetical patents, and we show the two types of networks we use. As we say, we are going to analyze first co-invention networks. Those networks, following the literature, are considered networks made of individuals, that is, inventors that claim to have registered a patent, and a link between two inventors exists if they have registered or collaborated in the same patent. So, for example, inventors 1, 2, and 3 are connected because they all have collaborated or worked registering the patent number 1. In the second type of networks, in the right, we can see the co-innovation networks. In those networks, the nodes are innovators. We call them innovators following the literature, but actually those are the owners of the patents. Most of the owners are firms, but organizations, research agencies, or public agencies, or even individuals can be considered the owners of the patent assignees. The literature calls them innovators because they are the actors who aim to apply this technology to the market. These actors are connected if they have collaborated with the same inventor. So, for example, innovators A and B, firms, for example, A and B, have collaborated with inventor number 3 in 2 different patents. So, inventor number 3 is kind of the channel connecting these 2 organizations or firms. We call them innovators. So these networks measure kind of interpersonal networks, and those are more considered like interorganizational networks. We analyze both types of networks and we compare them at the national level and at the regional level. This tells us something about the geographical boundaries. At the national level, we consider all the actors that are located on each of the countries, and we trace one network for each country. On each of the national networks, we also include the external nodes that are directly connected with the local actors. And we also trace the networks at the regional level, considering all the nodes and links in Latin America and the extra Latin American nodes that are collaborating with Latin American actors. In this video, I'm going to focus only on the national networks, but the regional networks, the regional approach is available in the working paper. Actually, in the working paper, we also elaborate country level and macro networks where nodes are countries and links are collaborations among countries, but we are not going to present this in this video. In order to study the temporal evolution of the networks, we assume that inventors and innovators collaborate before and after the date of the patent registration, and we elaborate following the literature 8-year windows to study how networks evolve over time. Okay, after elaborating the networks, we study their topological properties and evolution, and we particularly focus on 3 structural properties. First, size and evolution, the number of nodes and links. Second, the connectivity of the networks, that is the density or the extent to which nodes are connected among them, which may determine the nodeless flows. The connectivity can be an indicator of the absorptive capacity of the countries. The third characteristic we are interested in analyzing is the openness of the network. That is, if external actors are present in local networks, and also the extent to which foreign nodes are connected to local nodes. This could reflect internationalization of national invention activities with the consequent access to external knowledge and ideas. The idea was to generate a lot of comparative and descriptive empirical evidence, studying how the networks evolved over time. But in this video, I am going to present a small part of the evidence. Please consider that in the working paper, there are many more exercises that we have developed. Okay, to show you the results, first, before analyzing the networks, we present here a first picture of the patent data. In the figure in the left, we can see that patents are highly concentrated in the two largest countries of the region, in Brazil and Mexico, which they account almost for 3/4 of all patents in Latin America. Behind Brazil and Mexico, we can find other countries, or other large countries like Argentina, followed by Venezuela, Chile, and Colombia that we cannot see. So this was an expected result. Another expected result is that in the map in the right shows that the inventions are essentially concentrated in large urban agglomerations of the region. The leading Latin American hotspots are Sao Paulo and Rio de Janeiro in Brazil, Buenos Aires in Argentina, followed by Mexico City, Santiago de Chile, and Caracas in Venezuela. And now, elaborating the network, we start with the size and the evolution of the networks, counting it with the number of nodes on each network. We observe that there is a general growth trend in both co-invention and co-innovation networks, but with clear differences among countries, both in the size and in the evolution. We first find that Mexico and Brazil have much larger network than the rest. We also find in the other side that other countries have very, very small networks, countries such as Ecuador or Panama. In fact, in these charts, in these figures, we do not present the networks of other countries such as Honduras, Nicaragua, Guatemala, or Paraguay, because their networks are very small. Let me show you another graph with a comparison of the sizes of the inventors and the innovators networks. This is the number of inventors and the number of local innovators in the networks. And we can see that, first of all, there's a clear relationship between the sizes of both networks. We can see this group of relatively large size networks, particularly Brazil and Mexico, and then Argentina, Chile, Colombia, Venezuela, and Cuba. Then a group of intermediate size with smaller networks with Costa Rica, Peru, Uruguay, and Panama. Ecuador can be grouped here, the Dominican Republic, and then another group of with very small networks such as Paraguay, Honduras, Nicaragua, El Salvador, Bolivia, Guatemala. So we are particularly interested in this group of countries because these networks have complex dynamics in their structural properties. Those very small networks are highly conditioned by a small group of patents. So, for example, if one particular year one of these networks registers a patent with 5 or 7 inventors, then the density of the network is going to be highly affected. So the evolution of the indicators is highly volatile. So going back to the evolution of the sizes of the networks, another interesting finding is that even if most of the countries, almost all countries, increases the size of their networks, some cases, in particular the case of Venezuela, is interesting because the size of the network increases and then reduces, both in the co-invention in the left and in the co-innovation networks. So Venezuela experienced a sort of a reduction in the size of its network, and this is the only interesting case. Now, focusing on the connectivity indicators, we start with the average degree. In the left, we can see the average degree of the co-invention networks. In the right of the co-innovation networks. Please note that the case of Costa Rica here is not a relevant case since it has a very small network with less than 15 nodes in this year. So this high number of average degree is explained only by a single patent. So, except in the case of Costa Rica, what we find here is that there is a general trend in more clear in the co-invention network towards an increase in the average degree. we find that the largest networks such as Brazil and Mexico improve their average degree. Argentina also increases the average degree, but Argentina stands out particularly in the case of the co-innovator networks. So maybe showing that there is kind of a better connected network in the case of firms and organizations than in the case of Argentinian inventors. The case of Chile is similar in terms that we observe that the connectivity of co-invention networks has not improved, while in the co-innovation network there seems to be a more a better connected network. But the more striking finding here is the case of Cuba, which is a clear outlier in the co-invention network. The Cuban network has no isolated nodes by the end of the period, and their inventors have on average twice as many connections as those in the following countries. So we now delve into the connectivity of the networks by analyzing how they are fragmented or connected into large components. And to do so, we analyze the size of the giant components, of the largest components. In the left figures, we count the number of nodes in the largest components, and in the right part of the figures, we can see the share of the giant component of the giant components in the networks. The figures on top present the co-invention networks, and the figures below present the co-innovation networks. What we find here is that in the case of invention networks, if we take apart the case of Cuba, what we can see is that none of the countries have experienced the emergence of a giant component. Even if, for example, the cases of Brazil and Mexico increase considerably their largest components, those largest components represent only a tiny fraction of the nodes in the networks. So they cannot be considered a giant component of the network. They are largest, but they are not giant. However, in the case of Cuba, we can consider that there is a giant component, since there is a dramatic increase in the size with more than 200 and nearly 200 nodes in the last period, and also the share of the nodes that are connected to the largest component is significant. It's more than 50% of the nodes. So actually, if we observe the evolution of the Cuban network, we can see how in the 2002-2009 period there is a sudden emergence of this giant component. This fits into or can be explained using the Erdos and Rainey random network model, where the giant component emerges abruptly when the average degree increases. As we can see, it is not the average degree of 1 that predicted the Erdos and Rainey model, but it emerged in this period, and it maintained in the following period. Another interesting case here is in the co-invention network is the case of Venezuela, where a large component of more than 100 nodes emerges in 1994 and then reduces its size. And this large component represents a relatively important size of the networks. Let's see here in 1994, it's 0.2, more than 0.2% of the nodes, and then reduces dramatically its size. When we delve into this case, analyzing the graphs of the networks, the Venezuelan network, we observe how this large component can be considered a giant component, since it connects a significant proportion of the nodes. There is no other comparable components of this size. However, unexpectedly, in the subsequent periods, what we find is that this giant component, instead of continuing, it collapses, and the network is fragmented. So what we find here is a case of a network where where the Erdos and Rainey model can explain this evolution until 1994, and then afterwards this model doesn't serve. It is not useful to understand what is happening in Venezuela. And regarding the co-innovation network, the network made of firms and organizations, what we observe here is that the case of Argentina is the only one where we can consider that there is a giant component. Why? Because Argentina increased considerably the size of its giant component. As we see, those large components are smaller in size, is below 50 nodes, but it represents a significant proportion of the nodes in the network, with around 30% of the nodes connected to this giant component. So this is in line with the previous research we presented in the average degree, telling us that Argentina is particularly well connected when considering their organizations and firms, and not that well connected when considering its inventors, which may be reflecting a relevant feature of their national innovation system. So let's focus now on the other aspect of the innovation system measured by the openness, that is the extent to which national networks are connected with external actors. And to do so, we analyze in the figures in the top the presence of local versus national versus foreign actors. And in the figures below, we show the assortativity index, that is the extent to which local nodes collaborate with external actors. The figures on top shows that almost all countries have highly outward-oriented networks, and in particular regarding co-invention, in the left, we can observe that the countries with the larger networks are such as Brazil, Argentina, Mexico, Chile, and to show a lower levels of openness. On the other hand, countries with smaller networks, such as, for example, Costa Rica, Panama, Uruguay, and particularly Peru, register the greater presence of foreign actors. The case of Venezuela shows a strong tendency towards openness since 1986. However, this openness tendency, combined with the progressive decline of its network size and the disconnection of the network we presented below, may be revealing a weakening of the national innovation system with a greater dependence on external actors. So openness can reflect a good property of the national innovation system when the connectivity, the internal connectivity is appropriate, but when we observe a disconnection of the national innovation network, then openness may be reflecting a kind of a dependence on external actors. Another interesting finding is regarding the case of Cuba, that registers here the least externally oriented network in the region. So considering the high internal connectivity of this country, the low external orientation, what may be showing is an indication of a strong internal dynamism of its national co-invention network compared to the role of external actors, which is more critical in other countries of the region. Regarding co-innovation, in the left, the presence of foreign nodes seems to be lower, but in this case, it is worth to mention that the network openness of Uruguay, Argentina, and Cuba, while in the Cuban case, the local orientation of the co-invention network in relation to the external openness in the co-innovation network, we can observe it here. Cuba has a more oriented, externally oriented co-innovation network, that is the network of firms and organizations. This may be showing the existence of a strong national system of scientists and researchers that operates within a framework that is highly dependent on foreign firms and research centers. Finally, the assortativity indexes presented below shows that countries such as Brazil, Mexico, and Argentina increase their assortativity to a certain point when this indicator seems to stagnate. This could reflect a process of developing international collaboration systems that seems to give way to progressive presence of international collaborations. On the contrary, cases such as Chile, Colombia, and Cuba show that the index persistently grows. This is the time I was trying not. So in the cases of Chile, Colombia, and Cuba, the index grows, showing an increasing weight of local collaborations during the period analyzed here. So let me conclude. This paper has three major findings. First, collaboration networks in Latin America are highly disconnected. We find a constellation of separate groups of inventors and innovators, and this is observed both at the national level, that has been presented here in this video, where countries present very low density networks and very fragmented networks. But this is also observed at the regional level, where we corroborate the absence of a well-connected Latin American network. Second, despite this general disconnection, certain evolution towards an increase in connectivity, and particularly certain exceptions of countries can be found. For example, countries like Cuba show a strongly connected networks of inventors, while cases such as Argentina and Chile register highly cohesive networks of owners. The differences we found here between co-invention and co-innovation networks can illustrate distinctive features of national innovation systems. Third, our networks show a great dependence on international collaboration, as well as a clear extra-regional orientation of the links. And this may also show and corroborate what the literature on innovation systems in Latin America has previously stated. Our findings can also raise further questions for research. For example, will we obtain similar results if we consider sectoral and subnational approaches to our networks? Or is the effect of research and development and other public policies reflected in networks? And finally, how different types of institutional, political, economic shocks may have influenced our network. Is it possible to test structural changes in the networks? When do those changes happen, and why are they due to? So those are the further questions we aim to analyze in future research. Thank you for your attention, and hope you liked your presentation, the presentation.